Hello, good morning. Can you hear my voice? Okay, very good. Unfortunately, I understand now we do have Hong Kong is in a difficult situation, so that I think maybe some of you have seen the news, right? The number of new confirmed case in Hong Kong, right? This COVID-19 confirmed case keep increasing, so that I hope that all of you can be first is try to now make sure that you follow all the typical advice, right, from Hong Kong government, from UST. In public area, you wear the face mask and also try to wash your hand much more often, so that this is something is a difficult time. So that I do hope that all of you be very careful. As I mentioned last time, so that this Omicron, this virus actually it's a suspended aerosol in the air, so that this spread of this kind of mutant COVID-19 virus is spread so fast, and even inside the building, there's a risk, right? It can spread to through this kind of ventilation system. So that I just let you know that it is something we are in a very difficult situation, and of course, according to yesterday's announcement from our UST administration, so that unfortunately, I think we have to follow this our UST the policy, so that most likely for this year's this semester, this course, we can only have online course, and so that I'm sorry that it's not good for all of you. Compared with those typical this kind of classroom like teaching mode. So one student asked, of course, one student, Sun Mentong, asked a question about if the midterm and final exam were going to hell. Of course, I would mention in previous lectures, so that we will have the midterm and final exam. So according to the latest announcement from Hong Kong USC yesterday, so that most likely we'll have online the midterm and online final exam. Most likely, yeah. I don't, unless we lock down. You know that in mainland China, some big city like Xi'an or some big city, they lock down, and then everybody stay at home for maybe for a long period of time, and so that we can contain the virus. But I personally, I don't think Hong Kong government will follow this kind of a policy to ask all of you to stay at home for a long time, for 1 month. I don't believe Hong Kong government will have this kind of a policy. One more student also asked about if they're going to see some exam paper for midterm final. Yes, we will ask the TA to provide some sample like question for you to prepare for midterm and final. Okay, so that don't worry, so that we will look the thing. Of course, again, another important thing we mentioned is that as I mentioned last time, so that you according to our grading policy, so you need to you need to attend this online this kind of Zoom meeting and for this class as one of attendance record, so that the TA will try to use this Zoom system to check if you're online or not online. Of course, as also mentioned last time, so that when you attend this kind of online session for this our course, you are required to turn on your webcam, so that as a way to show that you are really actively attend these course, so that I just try to emphasize again and also try to let you understand so that we have a very clear policy put down in our syllabus. So the attendance is now through this online lecture is mandatory for you to get this kind of the grade and score, right? So that this is something please to make sure follow this kind of grading policy. Yeah, and of course, so that again, so that TA will try to we don't have homework, but we have this kind of online quiz for you to make sure have more this kind of interaction, right? Not just to listen to our lecture, but also you will try to study a little more about lecture note, and also try to give you some additional reference on our Canvas website. Again, so still, I still remind you, please turn on your webcam. Still, some students didn't turn on the webcam. So if you don't turn on the webcam, your attendance will be not counted. Okay, so that still we do have some students, right? Don't follow this kind of the policy in our grading policy. So please do turn on your webcam so that the TA will exactly follow the policy to check the attendance. Okay, because I do understand so that some student maybe just attend the Zoom and then still go sleeping or play video games. So that's something I do understand. Some students they don't follow the policy, so that please still we do have students, some students still didn't turn on the webcam. Please, or I just try to follow our exactly follow our policy. Okay, I just want to make sure that you this is something. Please do turn on the webcam in your Zoom. Okay, again, so that I don't know if there's others some question from about this course. Again, I do understand it's a difficult time, so that thing I hope that all of you will be all of you can go through this kind of COVID-19 pandemic this period. Of course, as I mentioned that I do have some special COVID-19 project, so that my peer student is working hard. At least 2 peer student working hard to make a rapid COVID-19 this kind of module. We can do this kind of testing of COVID-19 virus within 5 minutes. So if some student want to help, please let me know, so that I do have your project, so that if you have highly motivated and then you want to understand this kind of advanced, this kind of technology, so that you are welcome to think about to do some Europe project. I do have this kind of unique Europe project, so that I understand. You see, now there are many our Hong Kong people is waiting a long list, right, to do this kind of COVID-19 testing, right, so that we have a series of community this kind of test center, right? So that this is something I just let you know that I do have special project funded by the Shenzhen Hong Kong the government project, so to deal with this kind of issues, so that in case you are a highly motivated student, and then so you are welcome to try to take some my this kind of special project for COVID-19, so that's something. Well, I do think it's important, but of course it's also not easy, but it's something if you have some this kind of patient, and then so you're welcome to work on the project I'm working, my peer student, but not on UG7, but I do have UG student work on this thing. Let me quickly show you about this thing, so that if you, again, if some of you want to do, I think I do welcome some highly motivated student. Especially I do have one ongoing student who is doing an excellent job for one of my project. Okay, so that again, so this is something, it's a special difficult time now in the world. Global pandemic is something very big trouble. So that I just let you know, so that I do have a series of this projects, so that if you have some motivation, so that you are welcome to take this kind of Europe project with my peer student. And these are two peer student, PG student, work on this kind of low cost rapid pathogen detection, why for pandemic. So that again, so this is beyond this course, but it's important to now contribute the war, right? So that I just tell you, at this moment there's no such kind of product available, even in all the Hong Kong, the government sponsored the community testing. So that I just tell you, we do have a special funding from the government. So if you're interested, please try to contact me, and then I can let my peer student to give you some assignment. Okay. Again, this is beyond this course, but I do think it will be important and easy for all of you to think about this thing, right? How you can help, right? Your engineering skill. Now, if you upgrade your skill, you can do some meaningful this can work, right? I also have some microfluid device for cancer diagnosis, which is now in clinical study in 2 hospitals. So that's something I tell you, I have a unique research area, which is something I think is important, right? So that when we do research, you need to think about how you can contribute to the society. Yeah, so that's something I just let you know that although it's not mandatory, but it's useful and important to help people. Yeah. Okay, so now I think we need to go back to our lecture now, so that again, last time we already briefly mentioned about this kind of let me show you. Last time we briefly mentioned about our introduction slide, right? About this kind of thing. So that I don't know if you have any question about our lecture. No, we did mention last time. So again, the key thing is this kind of building. Where actually this code is give you some general education, right? To have the preliminary understanding about building engineering. So we cover most likely is selected the key aspect of the building engineering, right? So that and then in terms of what we try to for our building engineering, we take care for basic, right, mechanical design of the building, and then to let people to stay inside the building, and then of course we for most modern building we need to do some additional engineering design and control about temperature, humidity, pressure, lighting, air quality, noise, and probably another more important now is what pathogen control. If we are able to minimize this kind of pathogen, right? Pathogen means viruses or bacteria. So this is something at this moment it seems to be one of the most important issues. Yeah. And so that of course we'll quickly mention about for temperature. Last time we mentioned about human thermal comfort, this kind of zone. So this is related to in our mechanical engineering UG program. Actually, we do have some specialized course, right? This comes from what? This comes from the thermodynamic course. So that typically I mentioned for our engineering, experience engineering, we need to pay attention to not only temperature, but also humidity and the other. And so that this is a typical simplified way to describe about this kind of human thermal comfort. Of course, in the following ways, and actually I do have some more specific this kind of thing to describe this kind of human thermal comfort. Actually, one of my peer students really work on micro sensor to look at the human thermal comfort sensing. So it looks like it can be very complicated and difficult, right? So at this moment, there's no a low cost micro sensor to really do some real-time measurement about the human thermal comfort. But of course, we do have low cost as a micro temperature sensor and humidity sensor, but the human thermal comfort is much more complicated. Okay, and of course, we also care about pressure and lighting and air quality. So without mentioning and noise, right? As I mentioned, all this kind of critical building engineering, this kind of topic, actually, I will tell you, we'll have this kind of some corresponding sensor to do this kind of monitoring and control. Do you understand? So that is something quite important to let you know that that's why we have some one, I think, chapter talk about those kind of micro sensor, while possible application of a low cost micro sensor for the smart building, right, or intelligent building. So that that's something I tell you is seeing. And as I mentioned, that all the new smartphone you have, most likely you have pressure sensor, but it's a man's micro machine pressure sensor. It's not just for it's measure the kind of altitude barometric pressure sensor, right? So that I don't know if you have noticed that your smartphone has this kind of pressure sensor. Do you have? I want to ask you, do you have the smartphone which has the pressure sensor? Like, I think sometimes they call this thing now for other thing. Do we have this kind of pressure sensor? Not sure. If you are using this kind of iPhone, I think after iPhone 10, so that all the new iPhone has this kind of pressure sensor. So that of course, if you don't know, actually, I will also later on I'll give you some additional information, right? So how you can check your smartphones, all the sensor in your smartphone, right? Doing that, there's some free app can help you to dig out all the sensor available in your smartphone. There's a free smartphone app, so that well, that's I understand. So you just usually student, you haven't know all the more detail. Your smartphone now is very sophisticated. Typically, you have at least 10 to 20 sensor in your smartphone. Okay, so that's something I will give you some specific topic in the following weeks. And of course, lighting. So lighting is important. Actually, your smartphone also have a light sensor, proximity sensor. You are surprised? Okay, they call a proximity sensor. Why smartphone needs to have light sensor, upper sensor? Do you have an idea? Your smartphone have this kind of light sensor and also the distance sensor. Why your smartphone need this kind of sensor? Any idea? Because your smartphone can consume a lot of this kind of power. So that in this case, it will try to save this kind of power consumption in smartphone. So that you basically every smartphone have this kind of we call the proximity sensor. Proximity sensor, including this kind of a light sensor and distance sensor. Now using advanced semiconductor manufacturing. Manufacturing process. Proximity sensor, every smartphone, light sensor. Okay, and the distance and using it's called the time of flight. Time of flight is time of flight, TOF sensor. I will give you a little more information. Okay, so that every smartphone at least more than 10 sensors now. Okay, yeah. So it's just quite important and interesting. Right? Oh, one student say Chu Yin, you say you're right. So that some of the time of flight sensor can be useful to set power consumption. Smartphone can also use autofocus because this kind of just a LiDAR, but it's some special this kind of infrared sensor and infrared laser, right? So that they can try to do some autofocus. Okay, so student Chun Ying actually have a more idea autofocus. This is one application of the kind of proximity sensor in your smartphone. But anyway, I will give you a little more information in the following lecture. Okay. And of course, we also need to care about air quality. This is another very critical issue, right? So many big cities, we suffer about this kind of air pollution, right? Due to this kind of large number of cars, emission from engine, also maybe COP, electric power plant, and also air conditioning. And create a lot of this kind of trouble, right? So that and manufacturing plant, so that we do have this kind of air quality problem, and the noise is another issue, right? So that once you're a tall building and with so many people inside the building, and then so that how we can think about building engineering with proper material, proper design, so that you can minimize this kind of noise pollution. Again, your smartphone has some special app can use MEMS microphone to measure the noise meter. I told you, at least I told you, there's I do have a series of smartphone app to use the kind of a smartphone sensor for more professional application. Okay, so that I just tell you this is something interesting. So you may want to think about your smartphone as a new platform, SPLNFFT. This is a professional smartphone app, okay, and which can measure this kind of a noise using your smartphone, this kind of a microphone. Okay, so that I just tell you that so that your smartphone is a good platform, and then so that you may want to look into this kind of interesting, this kind of you see now I turn on my this kind of smartphone app, and then actually when I'm talking, so that this kind of noise, this sound level is about 86 dB. Okay, so that I just tell you that your smartphone is really a new type of this kind of way to not only for your as user smartphone, but maybe also useful to look at the building this kind of monitoring, right? Things like building engineering, so that this is something I tell you it's quite useful, important to think about how we can use this kind of MEMS micro machine sensor for not only for smartphone, but also smart car, smart system, or smart building is something quite important for all of you to think about. I can let me see if I can share this kind of my smartphone screen to you, and then you can see not only this slide but also to look at the real status of when I'm talking, right? When I'm talking this kind of thing, and then so that actually let me see if I can try to share with you about the noise condition when I'm talking, and then let me try to share with you about this kind of noise, the noise condition of when I'm talking, and that's also can help you to understand a little more, right? So you use your smartphone to understand the noise. That's a bit, I would say it's a quite interesting for you to have some idea about this kind of thing. Okay, let me try to see if I can share the screen now. Okay, you can see when you do talking, and then so that let me see if I can share with my smartphone screen, and then you can see about my screen. Can you? Hello? Can you see my smartphone app now? Huh? This is a real time. Maybe they don't. So that this is a smartphone app. Actually, it's a professional smartphone app. Use your smartphone. I'm using iPhone 10, so that you can see that they have this kind of professional this way to show this thing, right? So that I just tell you quite interesting and useful for you to understand this kind of our lecture note, not just static, is real time, so that you can see this is quite amazing. Your smartphone become a new platform, and then so that again, this is in a chat WeChat, so that no, in a Zoom chat, I told you this is the app I'm using is they call it SP. What's that? Anyway, so it's just very professional, this kind of thing, so that they can also look at the frequency domain, and then also much professional way to look at the thing, right? If very noisy, not very noisy. So this is something I just tell you, your smartphone is a new platform, can do many things. Okay, so that okay. So any question? Anyway, so just show you this is something, especially for this lecture, so that I do hope that you have more interaction, right? So that you just keep talking about slide, and then you may want to download this app. But this app is unfortunately, I don't think it's free. It's very professional, so that but maybe you can find some from free app, but the one I'm using is not free, but it's equivalent to about $2,000 professional noise meter. Okay, so I'm the one. That's why I at least tell you that your smartphone app is useful, and then so that if you are able to look how to leverage your smartphone app, then will be useful for you, and maybe you can write some special app for building engineering, right? So that I do have peer student also try to write this kind of combination of sensor with smartphone app, so that it can be useful for our smart building application. Do you understand? So that is something I just let you know that smartphone is a new platform, so that so many good idea, you can become very rich. Anyway, so that here I just show you this is a. Let me show you again, so that this is the one I'm using is this kind of professional SPLM noise meter. Okay, so that is and you can see it's not free, but it's really equivalent to about $2,000 professional noise meter. So that just tell you this is something I guess probably they have some free app, or if you understand about the mains microphone, understand about noise much more, maybe you can write this kind of a smartphone app to make money for building engineering. So that's to tell you this is something quite important, but it's something useful, I would say, to especially when we talk about noise, right? So now this kind of mains microphone is so cheap. So every smartphone have this one. So why not? You can look at this one at home to see, look at your home apartment building is very noisy or not. Okay, so that this is something I think is quite interesting. Of course, I also more than 5 years ago, I do have project about how to design and make this mains microphone. Okay, so that Hong Kong don't have this thing, but next to Hong Kong, there's one AAC company. It's Hong Kong public company who is top 3 in the world to make this kind of mains microphone for all the tier 1 smartphone maker like Apple, Samsung, and also the Huawei. So that Hong Kong doesn't have this kind of main company, but next to Hong Kong, Shenzhen, there's a one AAC company. They actually is top in the world to make this kind of a microphone, men's microphone. Actually, this it's a public company in Hong Kong. I told you it's a. I just tell you like Hong Kong doesn't have this kind of like semiconductor very strong, but Hong Kong do have a public company. The AAC is the stock code, right? It's I just show you it's a really big, super big company. I do a project with them. AAC is one of the top 3 companies in the world to make a men's microphone for smartphone. Okay, so that this is just something give you additional information, especially we mentioned about this kind of noise, so that it happened. I do have some project about this kind of microphone, men's microphone, and microphone with programming. Smartphone can make the noise meter. Okay, yeah. Okay, so that just give you this additional information. And of course, noise can be very dangerous, especially if you're close to the airport, and the noise from airplane can be very, very big. So that or noise near this kind of highway. So that these are some important things. So that so for construction, transportation, and these are, I think, some of important issue, right? So that of course, I think Hong Kong government, typical government has certain regulation, right? So that if you're nearby airport, there must have some limitation and how you deal with this kind of noise. Yeah. Oh, one student mentioned so that yeah, so this smartphone app for noise meter is not free, but it can just give you some additional information. You don't have to buy, but I guess maybe there's some additional smartphone apps free. Okay, yeah. And of course, odor is another critical issue, right? So especially for some like a commercial building, so that renovation, like so these are something quite important. And then some of this kind of odor can come from the maybe cooking, or odor from manufacturing, odor from maybe some combustion, right? Combustion, that means that there's some, for example, those kind of electrical power plant, and then they create this kind of pollution, right? So that the air pollution, yeah. So this is, of course, this is something it can important. Anyway, so now we gradually go into the much more detail. Typically, from engineering point of view, what is a building? So that of course, our engineering definition most likely will have well defined, so that it's a building which you most likely building will be some kind of a mechanical structure, right? And then using special material, most likely reliable material, because when in the old day we may use some brick, or now of course modern kind of building we most likely use the kind of RC concrete, reinforced concrete, right? But of course, sometimes in like for example in United States, I still remember, for example in California, a lot number of this kind of house, they're not using this kind of RC, reinforced concrete. They use it kind of the wood, you say, so that because I think this depends on this kind of the cost. It depends on how tall the building you're going to build. So that sometimes they still have using different material. Okay, so that this is something. And of course, typically building is of course is some mechanical structure, right? And then we have well-defined size, and then of course most likely the building is not a smartphone, right? The building, once that building you have to use for a long time. I guess at least in Hong Kong, typical building probably has I would say maybe 50 years lifetime. Okay, so that's something. But in general, I think typical building requirement is high, so we will try to use much a longer period of time, not just simply like a smartphone or things. So that, of course, in this case, reliability, right, is critical. So when you think that this building, so that we need to make sure that we will try to make sure that our building is can use for a long time. Right? But on the other hand, some country or region, the building design or construction is not very good, so that they may not be reliable. I still remember several years ago, there's one article published in the, I think, New York Times or BBC News, so that unfortunately in mainland China, some building can only that time only much shorter, maybe 30 years only, so or 20 years. So that I told you this is something is important, right? The building is most likely will be designed to be much, right? I guess most likely at least 50 years, I think, would be minimum to be more cost effective, right? If we have building built for 10 years and then it's too expensive and then create some big problems. And of course, in terms of building requirement, of course, most important thing is a mechanical design to meet the functional design. Why? You need to let this kind of people to stay inside the building without collapse, right? So this is functional design is one of the most critical in the beginning, and then gradually we will try to think about some additional issue, right? Performance requirement, and also, of course, typically for those building in a big city, most likely there's some requirement from the government, right? Every government has this kind of the building code. So this is the very important for building engineer, right? So that we call the building code, right? Hong Kong do have their own building code. In China, US, and I think every country have their own building code. So when building engineer design the building, they have to follow the local building code, right? To make sure that if you don't follow, and then sometime maybe suddenly the building will collapse and then a lot of people will die. So there's some very serious liability issue. Now, it's not a smartphone. If smartphone fail, then you will not kill people, right? If building fail, collapse, a lot of people will die. Unfortunately, we still, once a while, we still see there's some building sudden collapse due to the poor construction or use those kind of material which is not meet this requirement, or doesn't meet this kind of design, engineer, right? Design this requirement. So this is something quite important, yeah. And of course, there's other issue, right, in terms of this kind of thing, environmental impact and cost and the other thing, right? And also of course, at this moment, like Hong Kong government also require your building design have be more energy efficient, right? So that's why energy efficient building is another important aspect for at least for Hong Kong. So that I think it's critical. So that as you mentioned in the previous lecture, so that Hong Kong actually signed international I think agreement we have, because Hong Kong has very high this kind of carbon footprint per capita. I think almost top 3 in the world. So that there's some important pressure for Hong Kong government to really push this kind of design of the energy efficient building design. That's why 7 years ago I have some 10 million Hong Kong dollar project USD to work on smart energy efficient building design and using sensor, actuator, and AI. Okay, so anyway, so that there's a lot more details. So anyway, so as I tell you, in general, our building is really try to make sure that we can really first protect the people inside the building, right, against those typical weather or maybe in all day, and then have certain protection, and then to wind, rain, noise, and a lot more, right? And so this is a typical thing, yeah. And of course, building can be sophisticated, I also ask you, what kind of building is this one? This is something. This is some. We keep talking, and then. So this building is critical for you now, huh? A lot more. This Apple, the iPhone, and MacBook, or even the new advanced smartphone. Those processor most likely have to use TSMC advanced of 7 nanometer, 5 nanometer, this kind of advanced semiconductor manufacturing, the foundry, right? So this is 7 nanometer, TSMC 7 nanometer, this kind of fab to do manufacturing about advanced smartphone processor, like iPhone. I think my iPhone 10 is probably iPhone 12 most likely using 7 or 5 nanometer, right? So that so this is something I told you that TSMC is become the #1 in the world to make the most advanced this kind of 5 nanometer and this kind of FinFET transistor in mass production. And then so that as I tell you, this is one interesting. It's a 7 nanometer TSMC Fab 15, 7 nanometer FinFET transistor foundry in Taichung. And then of course 5 nanometer will be ready. The building in Fab 18 in Taiwan, and then so that this year they will finish this kind of a construction and install advanced this kind of semiconductor manufacturing equipment. So that UST, I was in charge of our UST clean room facility. It's not it's a research foundry. So that unfortunately all the university in the world cannot afford to spend like $1 billion, right, to build this kind of advanced thing. But we still have a good, this kind of clean room facility at UST, so that although we cannot compete with TSMC, but at least, but you can see, it costs a huge amount of money, for this kind inside the building. The cost is huge, It costs $18 billion, Now to make this kind of IC chip or processor, CPU, and AI chip, for iPhone, for GPU, CPU, and Huawei and thing, right? So that of course Apple or Intel, even Intel cannot make this 7 nanometer, 5 nanometer. The CEO of Intel actually flew from United States to Taiwan to ask TSMC to help them to fabricate 5 nanometer or 3 nanometer thing. So that I told you this, and you can see this kind of building is way much more expensive. Okay. So that as I told you, this is a very different knowledge skill to build this kind of building. Of course, what's the requirement? This kind of requirement is very unique, right? So do you have an idea? What's the special this kind of requirement for this kind of building for semiconductor foundry in terms of building engineering? Any idea? It's quite different, I would say. Any idea about this kind of building? Any idea? For this kind of semiconductor, the building for semiconductor manufacturing, its requirement is much higher. One of the most critical requirement for this kind of building for advanced nanometer, this kind of fabrication, what's the requirement? One student say pressure, humidity. Actually, one of the most critical for this, the building for semiconductor manufacturing is actually cleanliness, right? To say clean room, right? We call this clean room. We need to make sure that I think one student mentioned dust free, but how much is dust free? There's some specific requirement in terms of buildings. Like typically in our UST, if you look at our UST clean room facility, we have class 100, class 1000 clean room, right? But for 5 nanometer, 7 nanometer fab, wow, it's much higher. Requirement maybe class 1. Do you understand? So that is something but of course, in this case, you have special kind of ventilation system. If you look at our UST clean room facility, And then, of course, we don't spend that amount of money, but still, it's quite expensive. Even UST, we spend a big money to build this kind of clean room facility. Then say, I just tell you, all this kind of clean room is non-trivial to build. Okay, so that I was in charge to build our second clean room facility in Guangzhou campus. I thought it's quite expensive. Let me just show you the one I was in charge. We do have this kind of clean facility, right? And then so that it is in Hong Kong, our UST clean facility is I think most complete set of clean facility for semiconductor, our micro machine, main sensor, and microfluidic and biochip. So that I tell you, and we spend a lot of money. Okay, it's not small money. Why? Do you know how much money we spend? Huh? I give you some rough idea. How much money UST spend money for this clean room facility to make our research prototype or semiconductor microsensor? Do you know how much UST? Well, we didn't spend that $1 billion, but at least every year we a total amount of money UST spend, right? At least 100 million or 200 million Hong Kong dollar. I think I believe 100 million to 200 million Hong Kong dollar. Okay, for buy all the equipment, and every year we have to use about 5 million Hong Kong dollar for utility costs for this kind of ventilation system, because and then so that even electricity cost, right, is huge. Yeah, this 100 million to 200 million for equipment, for semiconductor, right? And then we have spent almost 5 million. 5 million. Wow, this is a quite $5 million for the utility cost, right? So every year for yearly utility costs for our HV energy. I just tell you, it's not easy. It's not easy. So that's why, well, if you're a student, maybe why not you try to learn something, how to leverage our big investment. UST most expensive this kind of thing is this kind of clean facility, right? So that we spend huge amount of money to sing. Okay. Anyways, I tell you, this is something, especially in this century, semiconductor become one of the most critical technology. So for every this kind of every country, China, US, Europe, Japan, all the big all of them put huge amount of money for semiconductor. They want to make sure, because this is something quite critical, right? If you don't have semiconductor chip, even some of automotive company, they will stop manufacturing their car. Do you understand? So this become one of a very important issue now for many industry. That's why it's something quite important. Okay, and of course there's another thing, right? For this kind of smart building, and so this kind of thing, it's not a office building, right? It's some building for manufacturing, so that for building management, and then sometimes we care about what, or not only let people to living inside this kind of building, is we have to let a large number of this wafer, silicon wafer, do manufacturing, right? So you see, this is, it can do 1 month, it can do fabrication of 140,000 silicon wafer. Do you understand? So that in this case, so they care about smart building, smart manufacturing. So it turns out TSMC has some advanced this kind of industrial 4.0. They use all the advanced this kind of semiconductor equipment, like extreme UV stepper from Netherlands, and then and also one extreme UV this stepper machine to do some photolithography. Is at least I remember it's more than 100 million US dollar. Do you understand? And then they also use all the sophisticated this kind of automation, fab equipment automation, transportation automation, and then machine learning, deep learning, and apply and a lot more sensor, and then big data. And then so in this case, they can do some smart manufacturing. And this is one of what most advanced this kind of AI powered manufacturing fab, semiconductor fab for your smartphone processor, for your CPU and thing. Yeah, and you see this 12-inch fab, as mentioned in previous slide, generate 1 million data per second. So that is something quite amazing, do you say? So that the semiconductor industry now have to spend huge amount of money to make sure that they can really has a much more efficient manufacturing process. So this is something I tell you like quite amazing, right? So of course in the following weeks I will give you some additional lecture about this kind of smart micro sensor and smart building, right, or something. So that's something I think it would be quite important, right? And then of course there's another thing. We also for building we also need to protect, right? This kind of sunlight and then this kind of solar radiation sometimes is good, sometimes it's bad, right? Some of this kind of solar radiation may cause some health problem. For example, if we have too much special kind of solar radiation from the sun, then may can cause some cancer, skin cancer, honestly. So that of course that's why I told you they also have your smartphone as additional light sensor, right? Light sensor, proximity sensor is combination of light sensor and also the distance sensor. So that in this case, they also have some special kind of smartphone app to turn those kind of sensor in your smartphone into this kind of interesting smartphone UV tracker or something. Okay, so of course you need to understand about the principle and how to use how the sensor in your smartphone work, and then you can think about to design this smartphone app. Okay. Anyway, this will give you some idea about this kind of issue, right? So that of course the building is a basic function, can really protect the human from this kind of exposure of this kind of a lot more solar radiation, right? So that's something. Okay. Then the next one is of course is about this kind of wind, right? So that for wind is another important aspect, especially for tall building. In Hong Kong, building engineer, we have to take care about, in general, there's two issues, right? We have to think about if some country and region have an earthquake, right? Earthquake engineering and also this kind of wind engineering. We need to take care about the wind loading so that the typical engineer to design the building, we have to look at the government's building code and then try to think about, okay, so that when you design the building and then you make sure that they have some special like a requirement, you have to make sure you can meet this kind of special kind of wing and then without any problem, without this kind of failure of this building or collapse of building. Okay. Anyway, so that of course typically this kind of big wind, right, come from the tropical, this kind of cyclone or typhoon, or depends on the location in the world, right? So that in Hong Kong we have this kind of typhoon, right, in the summer, right? So that in this case we in the I think 7 years ago, 2018, we have super typhoon, right? So that is very dangerous, right? A lot more building are going to have some big problem, right, doing that. So and of course when you have this kind of big wind typhoon, we also maybe additional storm. So this storm may cause some big problem, right? Of course, Hong Kong government do have a series of this kind of regulation and how we can try to minimize this kind of the problem, right? So that I think all of you will see, right? So that in case we're big this kind of storm, and then Hong Kong government will announce, right, about this kind of warning, right? So that anyway. So typically, I think all of you have seen we have this kind of the black, red signal for this kind of operation, right? For the office and also school, yeah. And then the next one is, of course, sometimes you have too much this kind of solar radiation, too hot, and then so the heat is another important thing we need to be very careful about this kind of building engineering, right? So that so typically, of course, if once you're very hot with this kind of weather, and then you can create some big problem, right? So that in this case, of course, in Hong Kong, especially we are in the tropical zone, right? So in this case, what we can do, of course, most likely we have air conditioning system, right? So that and then even you have a very hot, we can have a reasonable temperature inside the building. Of course, in some country region, they may not have this kind of air conditioning system. I still remember 7 years ago, I went to Berlin to attend international conference, and then they have a HVAC, they have a heating system, but they don't have some of this kind of building, they don't have air conditioning system. So I understand in some country region, not every building has this kind of HVAC system. Okay, and then of course, if you have this kind of extreme weather, of course we have global warming and the global this kind of extreme weather now, so that we may suffer of this kind of very extreme the weather, very hot, very cold condition, right? And then so it can create some big problem. Okay, and anyway, so I just quickly show you about this thing, and then of course finally I think we'll show you about inside the building, right? We have what do we have here? This is typical arrangement design for the building, right? First is we indicate about this kind of mechanical structure. That means we design the mechanical structure, and then so that in terms of mechanical design, make sure you can mechanical design, right? That is something, and so you can make sure we can consider about all the loading, right? You estimate an amount of this kind of loading, right? Human number of people, and maybe some equipment and other things. So mechanical design is one of first basic this kind of functional design for the building, right? And then of course beyond this thing, we also need condition about thermal comfort, right? Thermal comfort, I mean heat transfer, right? That means if a natural convection or forced convection from the air conditioning system, and then have lighting and the other thing, right? So you also need to look at some environmental control, and plus security and communication. And communication has traditional communication, we have maybe only telephone system, but now all the modern building, most likely, like our UST building, we have what? We have a Wi-Fi, and then for UST we also have a LoRa. LoRa, what is LoRa? LoRa is the most for this kind of IoT or this kind of thing, right? IoT application, so that a Wi-Fi have a much high data rate, wireless communication. But sometimes for IoT sensor, the most important is not the high data rate transmission of data. Is you must some of this kind of sensor in the building. We have to last for this sensor with maybe battery can last for maybe 5 years to 10 years. So LoRa most likely is the use of IoT sensors application. It can last faster, much longer period of time. And focus on 5G is also critical, right? In the near future, Hong Kong do have 5G now, so that 5G can have a big impact, right? In the future, we have a lot more smart car, a smart self-driving car. That every smart self-driving car have a lot more sensor, and all the sensor will transmit the data to maybe to the this kind of the whole system in the smart city, and then to the control about the traffic, what traffic light and other things, so that I can see this is quite important. Of course, another thing is passenger control, right? Sometimes inside the building we have what? We may have some pathogen, some bacteria. I still remember 1 or 2 years ago, one MTR station, I Choi Home MTR station, suffer about some special bacteria, right? That cause some sick building syndrome, right? Do you understand? So this is it. Of course, now we also suffer from this kind of COVID-19 virus, right? So that this is a, what I can say, bioaerosol. Okay, so it's a very, very small particle, right, suspended in the air. So this can create some big problem for over you, right? So this is something is important. Of course, how can we do this kind of control? Any idea? Do you have any idea? Any idea how can we do this kind of pathogen control, such as COVID-19 virus inside the building? Any idea? Some students control temperature or regularly negative pressure, some air cleaning machine. Well, I think negative pressure, negative pressure is one have been used in those kind of hospital, especially for ICU, right? In hospital, they make sure that the thing, but in typical building, residential building and also the office building, most likely it's too expensive for this kind of negative pressure. And another, Yi-Kuen mentioned some air cleaning machine. Yes, I think that's one alternative solution. And according to my that complication within, so some they use some kind of a new type of air ventilation system. I think one student Chong Yan To, and if you can install some special, maybe UV, some special UV light near the central air cleaning system, so that you can expose with some UV radiation and then kill those kind of virus and bacteria. So that's part of the thing. Sometimes they use this kind of UV light. Sometimes they use this kind of special plasma, air plasma. For example, like a shop, one Japanese company, they have this kind of a special shop, the air or this kind of purify system. That's a special kind of a plasma, so we can kill this kind of virus and bacteria. So that at least I tell you, I personally do study so how we can deal with this kind of difficult situation. For example, shop has this kind of air plasma, this thing air purifier. So this they do have done this kind of study. So this kind of air plasma has certain way. If you expose this kind of air inside the building with certain period of time, it's possible you can kill this kind of virus. Okay, so let me just show you one brief this kind of video from shop, one Japanese company explain about how they can try to use this kind of air plasma. They have some special name called the plasma cluster. Okay, so this is, let me show you this there. But there's multiple technology.
Sharp, a revolution in air treatment. We all know that cleaning our hands and surfaces helps to protect against the spread of germs and other contaminants. But what about cleaning the air we breathe? Our indoor air plays a vital role to our general well-being, but exposes us to elements that can make us ill or irritate us. Elements such as dust, bacteria, viruses, pollen, and mold. Introducing the Sharp range of plasma cluster air purifiers and generators. Our revolutionary technology is designed to effectively clean the air around us by combining our unique plasma cluster generator with a technically advanced airflow system, ensuring ultimate efficacy for a clean and fresh environment. Plasma cluster technology works by using an electrical discharge which creates positive and negative ions, surrounding them in water and releasing them into the air. These ions attach themselves to the surfaces of bacteria and viruses, where they bond together to form highly oxidizing radicals, which instantly draw out the hydrogen present in airborne proteins. This process breaks down the surface membrane of the protein, rendering it inactive. Finally, the hydrogen and OH radicals combine to form water, which simply returns to the atmosphere, leaving air fresh and clean. At the same time, plasma cluster ions work to reduce static electricity. The result? Pollen, dust and other contaminants do not cling to fabrics and furnishings. So, they can also be effectively collected and removed from the air through the advanced filtration system. This system combines a series of filters specifically designed for the effective removal of dust,
Okay, so it is of course we're in this kind of COVID-19 pandemic, so that it is I just give you some information for you to think about how you protect yourself, and then so that it is this kind of thing. I have been studying different types of this kind of way now to deal with this kind of virus, right? COVID-19 virus suspended air inside the building. So it is I have a series of reference about how this kind of plasma can kill this virus, right? So that I can give you this reference, but of course this is something is a reference material for you, right? So that the key thing here is I want to let you understand. So there's possible way we can really do to deal with this kind of COVID-19 virus suspend in the air. So that typically I think UV this kind of way this kind of UV can try to inactivate this kind of virus, COVID-19 virus, right? And then of course plasma I think this can also plasma, especially air plasma, right? Air plasma like here, yeah. So these are the possible way, air plasma. And the second and third method will be additional chemical, right? The third method is additional chemical, which can be also used to maybe you vaporize some special material, so that that material can be used to inactivate or kill this kind of virus material. One student mentioned, have you bought one? Actually, I bought not only one, I bought three. One is in my one's in my apartment, and two is portable one. When I inside my car, and also the portable one, especially now with very difficult, so that I sometimes I have this kind of portable one put in my backpack. Using the kind of the battery to power this kind of portable air plasma to protect myself. Not only wear a mask. At least personally, I bought three actually. One says, have you bought one? Actually, I bought three. I bought three. Okay, this kind of a sharp air plasma. I do study. This kind of air plasma. Okay, to protect my family member by myself. This kind of air purify. So it's kind of product. I bought three. And then I have another one is from this number 3 method is using some special material. You purify, you vaporize, and then you become the vapor in the air. So that I have another one, my old friend who is got the PhD degree in material science engineering at UCLA, and my old friend gave me a gift. It's Chinese New Year gift from this company in Shenzhen, and Dr. Li, actually, Li Haifeng is one of my UCLA old friend. He gave me a free this kind of gift, right? Kangfeng, I think that's a number 3 method which can be useful for you to think about this kind of how to protect you, right? So that I just told you there's a multiple technologies to protect you beyond this face mask, so that at least I just show you that I got this kind of free this kind of thing from my old friend, especially Hong Kong in this kind of a very serious, this kind of rapid spread of virus, so that I was lucky got a good old friend and provide me this kind of free additional free. Number 3, now I have a 4 this kind of air purifier now for protect myself, protect my family member. I got another free gift from my old friend, and this is they do have sell this kind of medical, this kind of ventilation system used in Hong Kong hospital in hospital in mainland China. I told you I got now I have a 3 plus 1. So I tell you that it's important to let all of you know that how you protect yourself. And my old friend also provide me a free this kind of special face mask with some special KOF material, so that it's actively so typical surgical face mask have no this kind of thing, right? So at least my old friend also sent me the free special face mask to protect. I'm really grateful to have a very good old friend send me the free one, so that this kind of difficult thing here, so that I tell you, just to share with you that at least I have 4 air purifier with thing, and then additional is this kind of AOF. I just share with you so that at least you understand this kind of face mask. The thing, I wear this kind of active, this kind of a mask to protect, especially this kind of Omicron is spread so fast, so that this is something I just share with you of how I prevent myself, so that if you want to understand, at least provide you this kind of special this kind of way to protect yourself, so that this is something especially it's difficult moments, so that I do hope for you try to find the best way to protect yourself and protect your family members. So do you have any question? I just tell you that I personally I do have a PhD student in bioengineering. You will be surprised. my PhD student using virus to do research, but not COVID-19 virus. We have special kind of a phage virus to micro the biosensor, and so things. So I don't scare. My lab don't have COVID-19 virus. I have special virus to attack bacteria. So I do have PhDs from our MEE and BME by many names, so that I do have my second PhD student actually have been working for US FDA for more than 10 years. So that of course, I will try to, if you need additional understanding about COVID-19, so I have some special connection through the FDA. So of course, I try to think about, especially some students or some people concerned about vaccination issues. So that of course, I do, like last year when I try to, before I take this kind of want to take a vaccination, actually I consult my former peer student who have been working in US FDA for more than 10 years to see what's the best way, right, to do vaccination. Anyways, I tell you, it's a difficult situation, so that I just share with you about this kind of additional thing. Hopefully, all of us can overcome this difficult situation. Of course, if you're interested about this kind of project, and then so for you're welcome to join my PhD student work on this kind of a rapid detection of this kind of this kind of biosensor system with plasma, the PCR. Anyway, so that's something is beyond this course, but I just tell you something. I have my own research, a group of PhD students work on this thing to funding from the government funding. Yeah, because at this moment, see, if you go to the community test center, they take your sample and then you have to wait for maybe tomorrow or the next day you can get the result. But if I have this new technology, 5 minutes, you take sample in the community center and then 5 minutes, you know you got virus or not. I think it's a it's a critical technology, but we are still in R&D stage, so that we do need some additional manpower, so that I have a big funding for the postdoctor funding. So I will hire a lot more postdoctor to work on a lot more this kind of a microsensor technology. So that this is a 300 million Hong Kong dollar project, right? Funded by Hong Kong government. Yeah. Okay. Anyway, so that do you any question? Any question about COVID-19? I do think it's one of a difficult time for all of you. Any question? At least I provide some actual information for you. Hopefully everybody, at least, unfortunately yesterday we do have one student got the COVID-19 virus infection in the math department. I think I checked with the professor in math department, it seems it's confirmed. So that's why I just let you know that we're in the difficult situation, so that please do follow this kind of policy and make sure that you protect yourself. You know, that's something. We do have one, I think, student in math department seem to be confirmed the COVID-19 case. Okay, so that I hope that you will not get this virus. It's something difficult time. Okay. Anyway, any question about this thing? We are in a difficult situation. Any question you want to ask about COVID-19? I have special this kind of project, and I have PhD student now work for FDA for more than 10 years. So that if you want to know more, and then you're welcome to ask this kind of information. Okay. If not, then I think one student asked. One student asked, Chun Hey Lam, is any way to auto detect COVID-19 in water or air? Unfortunately, at this moment, there's no commercial product. Yeah, one student, Chun Hey Lam, there's no, but at least one of my old friend, there's one professor in University of Arizona. He has been working on this kind of technology, but I don't know if his technology is become real product. So this is a very good question. Auto detection, that means basically you need to have some special microfluid device, and then to do sampling, collection of those kind of sample viral subject area, sampling, and then processing. All those kind of capture those virus and then sample processing and then detection. So you need to have a series of this kind of microfluidic and biosensor to do this thing, so that at this moment, as I told you, I see probably there's no such kind of product, but there's some startup company try to make this kind of integrate microfluidic device and for this kind of application, but I don't think it's in the real mass production at this moment. But that's why this kind of my research has some important thing in the near future, right? So that hopefully, you see, I have a 5 minutes, right? 5 minutes to do the kind of plasmonic PCR, and then it's close to the thing. And then if you have a lot more this kind of integration, but we do need some young, energetic, this kind of student who work on this project. So that I think this is a very good question from the student. But at least, I will give you one example. And this is one start company from AMEC. It's one top micro and nano electronic center in Europe. And I know that they have this kind of silicon microfluid system for this kind of COVID-19 thing, but I don't think it's in mass production yet. Anyway, so that this is a very good question from the student Jung Ham. I will give you this example as company. At least 7 months ago, they say they have become the start company. So that this is something difficult time. I do believe in the near future, this kind of real-time biosensor and with microfluid should be developed for this kind of smart building in the near future. There's no doubt at all. But you have to low cost. Low cost is important. You say typical way at this moment is time consuming. It cannot be likewise. The micro technology using semiconductor micro technology is important. Okay. I think we run out of time. So that I will try to provide information to the student overview on our campus website. Chun Hey Len, the question is very good, and provide at least one company and also one of my friend professor in Korean professor in University of Arizona. I know he has been working on this area for many years. Yeah. Okay, I think that's it for today's this kind of lecture. First things, please follow this kind of typical policy. Protect yourself. I guess the number of new cases will keep increasing exponentially. We are in a difficult time. Okay, anyway, so that goodbye, and hope we can overcome the difficult